This is Google Cloud Basics. Next up, Google Compute Engine.
Google Compute Engine provides virtual machines in the cloud. GCP instances are available in many different types or families. These instance types are typically optimized for a specific workload, such as compute, memory, or additional hardware such as GPUs and TPUs. Each Compute Engine instance will belong to a GCP project and a GCP region and zone. Instances can use local SSDs and persistent disks, as well as other cloud-managed storage and databases. Each instance can also be attached to one or more VPC networks. Premium networking also provides access to Google's high-speed, low-latency fiber backbone. Instances can use fine-grained access control through IAM permissions, service accounts, firewall rules, and advanced tools like Security Command Center. Compute Engine supports images and templates, as well as various deployment strategies such as standalone VM, unmanaged and managed instance groups. Compute Engine can be consumed a number of different ways, including spot instances, sustained use and committed use discounts, annual commitments, and enterprise discounts. Free credits and free product tiers are also available.
This is Google Cloud Basics. Next up, Google Compute Engine.
Each GCP resource will belong to a GCP project. A project organizes all of your Google Cloud resources. It consists of users and authentication, APIs, billing, and monitoring. You can view all of your projects from the console, including any top-level GCP organizations. If you select a project, you can view its settings. To create a new project, specify a name, organization, and location. Once you've used any free credits, you will need to associate a billing account and payment method with the project. Billing can also be viewed from the console.
is Google Cloud Basics. Next up, Google Compute Engine.
Google Compute Engine uses regions and zones. A region is a specific geographical location where you can host your resources. Regions have 3 or more zones. Using multiple zones in a region reduces the risk of an infrastructure outage affecting all resources simultaneously. And using multiple different regions provides an even higher degree of protection from failures. And to automatically manage multiple instances across multiple regions and zones, you can also set up a managed instance group. Using regions and zones allows you to design robust systems with resources spread across multiple geographies and failure domains. All sat on Google's high-speed global fibre backbone.
This is Google Cloud Basics. Next up, Google Compute Engine.
A VPC is a private, isolated virtual network partition that provides network management functions for other GCP resources. It provides connectivity, firewalling, and routing functions. Traditional VPCs are bound to individual regions, but Google Cloud VPCs are global in scope and can span multiple regions. This means GCP resources can communicate across other regions without needing VPNs or other complex routing. VPCs are global and network subnets are regional, and individual zones sit on top of these regional subnets. In this example, GCE instances 1, 2 and 3 are all in different zones, but within the same region. Because they are on the same regional subnet, they can all communicate directly with each other on internal IP addresses. The same applies in other regions for instances 4, 5 and 6, and for instances 7, 8 and 9. If VPC firewall rules allow, Each instance can also talk to any other instance in the VPC directly, because VPCs are global. VPCs can also be used with shared VPC, Cloud Router, firewall rules, VPC peering, and Cloud VPN.
This is Google Cloud Basics. Next up, Google Compute Engine.
Compute Engine creates virtual machine instances based on Intel, AMD, and ARM CPU processor architectures. In this example, we are selecting a Tau T2A instance based on an ARM Ampere CPU. Multiple instance types are available, including N1 and N2 general purpose on Intel, E2 general purpose on Intel and AMD, and N2D general purpose on AMD. Tau T2D general purpose on AMD, Tau T2A general purpose on ARM, Many instance families also offer a higher or lower memory to CPU ratio. C2 on Intel for compute optimized. M1 and M2 on Intel for memory optimized. A1 on Intel and NVIDIA GPU for accelerator optimized. Custom instances are also available if required, but may be slightly more expensive.
This is Google Cloud Basics. Next up, Google Compute Engine.
Good morning and welcome to Security 101. Welcome. We've got 4 security topics for you today. Identity and access management, network security, application security, and data security. Let's go. If you are new to identity and access management, you could start with IAM permissions for users and groups, Cloud Identity for user authentication, service accounts for when applications and services need to communicate with other applications and services. If you are new to network security, you could start with firewall rules to control access to ports and protocols, VPC service controls for perimeter security, key management for encryption of data in transit. If you are new to application security, you could start with Cloud Armor for protecting applications, Apigee for API endpoint security, Recapture to protect your website from fraud and abuse. If you are new to data security, you could start with BeyondCorp Enterprise for Zero Trust, Identity-Aware Proxy to control user access and authentication, Data Loss Prevention to protect sensitive data, Security Keys for data encryption. One more thing. Don't forget about Security Command Center for central management of security tools.
This is Google Cloud Basics. Next up, Google Compute Engine.
To be able to set up Compute Engine networking properly, we need to understand a few things. VPCs or virtual private clouds, GCP regions, GCP zones, network subnets within regions, which zone are compute instances running in, and how to attach one or more network interface cards, NICs, When creating the instance in the console, we first need to expand the Advanced Options section, then expand the Networking section, then select the Network Interface or NIC that we wish to configure, From here we then select the network which corresponds to our desired region. Then we select the name of the subnetwork which corresponds to the desired network subnet or network segment. For the internal IP, we can select an ephemeral IP address. Ephemeral is just another word for temporary. Or alternatively, we could request a static IP address, which is not temporary and should not change over time. We can optionally repeat this process if we also require an external IP address, in addition to the internal IP address we just set up in the previous step.
This is Google Cloud Basics. Next up, Google Compute Engine.
Google Compute Engine supports various types of storage, including block, object, and file. Local SSD is block storage which is accessed directly from within the operating system. It is non-persistent and data can be lost when the instance is shut down. It should only be used for temporary files. Persistent disk is persistent local block storage which is accessed directly from within the operating system. It is commonly used for virtual machine disks and any locally installed databases. Persistent disks are available in many different types that can be used to balance performance and cost. Object is persistent storage which is accessed via an API and a universal resource identifier. Cloud storage stores files and any associated metadata in buckets and is available in multiple different tiers. Filestore is persistent storage which is accessed over the network via the NFS protocol. Filestore provides a shared file system for individual files and folders and unstructured data.
This is Google Cloud Basics. Next up, Google Compute Engine.
With Compute Engine, there are a few different ways to install software. In this video, we will cover two of them, via an SSH session and via a startup script. In the first example, we will install the Cloud Operations Agent into an existing GCE instance. In the second example, we will install the Cloud Monitoring Agent and the Apache web server from a startup script onto a new GCP instance. For example 1, we will start an SSH session from the GCE VM instances page. I'll paste the code below into the SSH session to copy the installation script to the VM using the curl command. And then run the next command to install the agent. After a few minutes, we can check the agent status in the monitoring section. For example 2, we will install the Cloud Operations Agent as before, and the Apache web server on a new GC instance from a startup script. and then open port 80 for HTTP access. The only option I'm going to change is the selection box to enable HTTP access for the Apache web server. Then click through to the Advanced section, then Management, then to Automation, where we can see the Startup Script text box. And then paste in the code below to install the cloud monitoring agents as before, but also install the Apache version 2 web server. Then finally create the instance. After a few minutes we can see the agent in the monitoring section and check the default web page in Apache version 2.
This is Google Cloud Basics. Next up, Google Compute Engine.
In a previous video, we covered installing the cloud monitoring agents and the Apache web server. In this video, we will create another instance running the cloud monitoring agents and the Nginx web server. We will then create an uptime check for the Apache and Nginx web servers and view them in the monitoring dashboard. I'll create a new instance with the default settings. Here I'm going to tell the firewall to allow HTTP web traffic. And here I'm going to paste some code into the startup script text box to install the agents and Nginx web server. We can click the external IP link to check that our new Nginx web server is working correctly. From the monitoring section, we can generate uptime checks for our web servers. Firstly, provide a name for the uptime check. Then specify the instance to monitor and the response codes we are expecting from a healthy instance. For each instance with an uptime check, we can view the current status. Each region will show a red, amber, green status if uptime checks are in place with accompanying charts.
This is Google Cloud Basics. Next up, Google Compute Engine.
When creating a GCP instance, the VM will need a boot disk to start up from. We can pick from a number of public operating system images. Most are free to use, but some premium images, such as Windows Server, are charged for by time or CPU cores in use, as well as the usual persistent disk storage charges. Alternatively, we could select a custom image if we've already created one from another VM boot disk. Custom images often contain any required applications and services, such as a web server or any monitoring agents. Although primarily designed for backup purposes, snapshots can also be used as long as they contain a valid boot image. Even archive snapshots can be used as a boot disk. And lastly, an existing disk that may have been connected to a different VM previously.
This is Google Cloud Basics. Next up, Google Compute Engine.
A custom image is often used to build an image that already has any required software installed and any required configuration changes to save time and provide standardization. As well as free images, you can also select premium images. Microsoft Windows Server, Microsoft SQL Server, and Red Hat Enterprise Linux are all examples of premium images. Disk snapshots can be created from existing disk images. Simply provide a name, description, source disk, and a location to store it. It's the same process to create an archive snapshot, just change the type to archive when creating. When deleting a VM instance, you can either keep the disk to use with another VM or just delete both together. You can also detach the disk from a VM instance as long as it's not currently running. Local SSD provides high-speed storage for temporary files. All contents will be lost on power off or deletion. Local SSDs must be added at machine creation time. Select an interface, SCSI or NVMe. How many SSDs to add? This will dictate performance. NVMe is fastest but requires a compatible boot disk OS. Select how many SSDs to attach. The estimated performance will then be shown. Then confirm your selection. This command shows the two new NVMe devices selected. Next, we need to create a file system. Then make a directory to mount the device under. Repeat for any other new block devices. Disk free shows that the new drives have been added. Notice that we cannot stop, only suspend or delete, or add any more SSDs after initial creation. Filestore can provide a shared network file system to multiple clients using the NFS protocol. It provides similar functions as a traditional SAN or NAS. Files and folders can be shared between instances, clusters, and other cloud services. Select a name, description, and a service tier: basic, enterprise, or high scale. Then select either a hard disk drive or solid state drive storage type and the total storage capacity required. Choose a region, zone, and VPC network, as well as an automatic or custom IP address range. Lastly, select a file share name and the method you wish to use for access control on the network. During creation, a summary of cost and performance can be seen, which updates dynamically as you make selections. Once the Filestore instance is created, we can view the details. Including the current resource status and any backups. When creating a compute engine instance, it is common to use local SSDs, which we discussed in a previous video, and persistent disks, which we will cover next in this video. Starting with the lowest performance and cost option up to the highest performance and cost option, we have standard persistent disks are backed by hard disk drives. They are suitable for large data processing tasks that use lots of sequential I/O. Balanced persistent disks are backed by solid-state drives. They are suitable for most general-purpose workloads and provide a good balance of price versus performance. Performance persistent disks are backed by solid-state drives. They are suitable for enterprise applications and high-performance databases that require lower latency. Extreme persistent disks are backed by solid-state drives. They are particularly good for high-end database workloads such as Oracle and SAP HANA. A persistent disk with a bootloader and boot file system can be exported as a custom disk image. And conversely, an existing disk image can be re-imported back again as a new persistent disk boot disk. For backup purposes, any persistent disk can be backed up to a disk snapshot, or after any data loss or corruption, restored back from a disk snapshot. A persistent disk can be created blank or from an image or snapshot, detached, reattached, or deleted if no longer required. A zonal persistent disk consists of a single copy in a single zone. A regional persistent disk maintains a primary copy and a replicated copy in two different zones within the same region. Compute Engine supports many different operating systems, including Microsoft Windows Server. To create a Windows instance, just build a new machine as you would normally, but at the boot disk section, change the boot disk to a Microsoft Windows Server image. Windows images are classed as premium images due to the additional licensing costs they also add or incur. Once created and booted up, we need to set a password for remote desktop services. Make a note of this username. Make a note of this password. Now copy and paste the external IP address of the Windows machine into a remote desktop client. You will then be prompted for the username and password set up in the previous steps. You may receive a warning about the machine having a self-generated certificate. The machine will then log in. And launch any startup tasks and services.
This is Google Cloud Basics. Next up, Google Compute Engine.
Compute Engine will send logs to cloud logging if you have the agent installed inside any VMs. This is the main logging dashboard. Here we will highlight the queries, filters, events, the log entries, and the log details. You can use a predefined report or create one of your own using the filters. Here we're filtering by all VMs. And here we're filtering by a specific VM, in this case VM example 1. And here is the actual query text that was generated by applying those filters. Next, we will set up a log sync to send logs to another location. Our first log sync will send logs to a Google Cloud storage bucket. We provide a sync name, destination storage bucket, and any filters for what events to include or exclude. Our second log sync will send logs to a BigQuery dataset. We provide a sync name, destination dataset, and this time I'll paste text in from a filter I created earlier. Billing can be broken down by cost or by project. individual budgets and alerts can be configured. Email alerts can be sent when certain thresholds are reached. Budgets can be set over monthly, quarterly, yearly, or custom time periods. Actual costs and forecasted costs are shown for the remainder of the billing period. Budgets and alerts only provide information. They do not automatically apply a hard cap on spending. For extremely detailed billing analysis, billing can be set up to automatically export data to BigQuery. GCP supports three main types of labels and tags. Labels are primarily used to filter on billing. Tags are primarily used to apply organizational policies. And network tags are primarily used to apply firewall rules. Labels can be set on individual products and services. And are used as key value pairs. Each key may only be specified once per resource. So for example, component front-end and component Apache labels on the same resource would not be allowed. A tag can be attached to a Google Cloud resource. They are created as individual keys with multiple possible values. You can use tags to conditionally allow or deny policies based on whether a resource has a specified tag. They are created centrally at the org level, but are then optionally applied at the org, folder, or project level. A network tag can be attached to VMs and VM templates. A tag is simply a character string added to a tags field. You can use tags to conditionally allow or deny policies based on whether a resource has a specified network tag. They can be useful in VPC firewall rules, where resources and IP addresses are changing on a regular basis.
This is Google Cloud Basics. Next up, Google Compute Engine.
Labels can be used with many Google Cloud products to make it easier to filter items in the billing console. From the Compute Engine VM Instances page, show the More Info panel on the right-hand side of the page. Then select one VM instance at a time to view any labels associated with it. You can add a label from the same screen by clicking Add Label. And providing a key and a value, also known as a key value pair. You can also show labels in the main view by using the Displayed Columns icon. These labels now allow you to filter items in the main VM Instances screen. And also filter in the main billing screen. Filtering here by the new fruit labels we just created. Or by component. Or by environment.
You've been watching Google Cloud Basics.